This conference is brought to you by CallStack, your React and React Native development experts.
Hi, my name is Adam. I'm a senior engineer at Klarna. I am member one of the core teams where we take care of foundations of our React Native app. To give you a little bit of context, Klarna is a global AI-powered payments network and financial assistant. Technically, we are a fully licensed bank. We have over 100 million customers all over the world. And we have a large monorepo where we ship our app to 4 different platforms, iOS, Android, web, and browser extension. So what is the goal of this talk? Well, over-the-air updates for React Natives allows you to deploy changes to your clients without doing the native release. And there are already a bunch of solutions for React Native that promise agility and resilience. And actually, when you read the docs, they make it look really simple. They will show you a little bit snippet of the code you need to add to your app, and then a little command you need to execute, and all of your clients will magically, instantly get the update. On one of the web pages for such solutions, you can literally read. You can send an OTA update directly to your end user with a click of a button. No more tedious App Store, Play Store releases. Yeah, really? No more App Store releases? Can they keep up to their promise? At Klarna, we implemented our own OTA solution completely from scratch and deliver our solution to millions of users. But this talk is not only about to tell you how we build it, but it's also about giving you a better understanding of how OTA in React Native can work in general, and show you some interesting complexities behind this. So even if your ChatGPT wrapper has not reached 100 million users yet, you still can benefit from this talk. If you want to implement OTA updates, you will be able to choose and evaluate different solutions and choose what fits best for your team, your app, and your release process. So the rest of the talk will make more sense if we first answer the question why and how OTA is even possible in React Native. So let's start with web, because this is something we have a good understanding. So your web application is split into 2 different parts. There is your JavaScript bundle, or all the code you write and deploy. And there is the browser, the native side, let's say. And the browser is just executing your JavaScript. And the browser doesn't really care much about your JavaScript, as long as it can run it, and it's aligned with the API that browser provides. Is React Native much different from that? So let's have a look at another slide, and let's see the difference. Have you seen what was changed? In a way, React Native works exactly the same as the browser. There is this native layer that just runs your JavaScript, and this native layer doesn't really care much about your JavaScript as long as it can run it, and it's aligned with the API. The only difference is that you control both sides of your app, so you have new, fantastic, and creative ways to crash your app. And to prove this to you and give you a little bit better understanding of this, I created a small repository with a bare-bone React Native app and instructions how you can build your app, then extract this, change the JavaScript manually, pack it up again, and install on the device. And you can see that your app will be updated without actually rebuilding the app. And so what is also important, your JavaScript bundle physically lives somewhere in your file system. So at this point, you might be starting to get a feel how over-the-air updates works. And I can almost see these engineering wheels turning in your head. It's a part of being an engineer, right? Walking around, looking at different stuff and thinking, I can build that, right? That's what we do. So maybe you are imagining, can I just vibe code some native logic that will call my server and download the newest JavaScript bundle and just replace it on the file system so React Native can execute the new version? Well, if you think it's OTA, it's that easy, well, yes, congratulations. You just invented how the OTA works. Good work. And also, this shows you, probably shows you the limitation of the OTA, that you can, with this, you can ship only JavaScript changes. If you have native changes, you need to go through the store. But there is one more question, the kind of question you can ask during any meeting, even if you haven't been paying much attention. And if you will ask this question enough times, you will finally become a senior engineer. And the question is, does it scale? And the answer is no, not really. Seriously, don't create your OTA solution completely from scratch. And don't get me wrong, the principle is correct. That's how it works. It's just a bunch of different stuff that you need to consider to make it work at scale. So let me show you how we build this. I will briefly walk you through the simplified architecture diagram. So we have a backend service that is connected to our pipelines. And this service works as a source of truth for all of our builds and versions and artifacts and artifact locations. And we store them on the S3. We also have another service that works as an API for the client, so we can control OTA rollout. And our mobile app periodically checks with the server if there is a new update available, and if there it is, service returns link to the S3, so the app can download and apply the OTA by itself. And on the native side, we wrote our own custom OTA library that allows us to keep all the logic for managing JavaScript chunks on the device. So if I say somewhere in this talk that we implemented something, most probably I mean this library. So there is our next question, how to actually force React Native to use the new bundle that you just downloaded. Well, for this we are using Re.Pack. Just curious, how many of you are using Re.Pack in your project, have some experience? All right, I can see your hands, nice. So if you're not that familiar, Re.Pack is like Webpack, but for React Native. And Re.Pack helps us in two ways. One, it lets us to do the code splitting, so our final bundle is split into multiple smaller chunks. Remember that, because this will be important later. And the second, it allows us to programmatically choose how our JavaScript bundle is loaded. So there is a feature called Script Manager, and it lets you write your custom logic. So for example, you can even provide a link to the CDN, and Re.Pack is able to download this JavaScript and execute this. But it's not what we want, because we need almost native experience, and we don't want clients to have to wait until the bundle is downloaded and executed on the device. This will generate a lot of traffic and consume customers' networks and battery, so we don't want that. So instead, we can return a path to the file in the file system, and because we know where we downloaded our artifacts, we can just point Script Manager where the chunks are located. So how do we actually generate the update bundle, so the bundle that we are downloading from the server? Well, the simplest way will be just create the whole bundle, put it on the server, and let clients download it. This sounds easy and convenient, and in React Native you have scripts that will build only JavaScript bundle. But is it really a good idea? Can we ship the whole bundle to the clients? So let's do a quick math here. Our JavaScript bundle, even gzipped, weighs 64 megabytes. And if you will multiply this by 85 million clients, that's how many total downloads of the app we have, this will generate over 5,000 gigabytes of data, of traffic. How much do you think the costs will be using CloudFront? Any guesses? It will be around this, just for one OTA update shipped to all of our clients. And on top of that cost is, again, client's network and battery usage. So we care about keep it efficient. So shipping the whole bundle is not what we exactly want to do. So can we be smarter than this? Yes, we can create a diff and ship only the difference, ship only what was changed. Let me show how this one works. Remember earlier, we have a service that have a knowledge about all of our builds and artifacts. So what we are doing, we are extracting and fetching and extracting the artifacts for 2 versions. So as you can see on this example, you have version 1 that is already released to the clients, and you want to apply v2 on top of that as a OTA update. So what we can do, we can just extract our bundle and calculating and comparing the checksum for each files, we can see exactly what is changed. So as you can see on this example, we have 1 chunk that is changed and 1 that is new. So only those 2 will go to the bundle, so to the update. So effectively, we can reduce from tens of megabytes to just a couple of 100 kilobytes. So it will be way more efficient. But most probably, your React Native app is producing only 1 main chunk. Can you still somehow get the diff instead shipping the whole new bundle? Yes, you can. But you need to remember 2 things. If you didn't mess up anything, your JavaScript bundle is a compiled bytecode. So it's not plain text, it's a compiled bytecode, so Hermes can execute your JavaScript faster. And what's important, binaries can be diffed. And it's not only limited to Hermes, it's like more general concept, so you can have, for example, 2 Windows executables and create a diff between them. However, there is a catch. What is this? The diff that you may create between 2 bytecodes may be almost the same size as the update bundle. Why is that? Because even small changes on the JavaScript side can generate a cascade of changes in the compiled bytecode. If you will have a look at this example, you see that the change is really simple. We just added some items to the array. But you can see that all of the indexes are shifted. So bytecode, in the end, the bytecode diff can be pretty large, even if JavaScript change was relatively simple. But Hermes got you covered, and you can reduce the diff size. And Hermes got a special option called base bytecode that you can use when compiling your JavaScript. Don't worry, we are going low level here. You are looking at the disassembly of compiled bytecodes from the previous slide. Don't worry about analyzing anything, but you can see that we used the main bundle as a base bytecode, and Hermes was able to reuse the identifiers for the strings that we are using. So the update bundle is more like the main one, so the diff can be also much smaller. Pretty neat, right? But things can go wrong. So what we did to harden our architecture and make it more reliable. Let's talk about 2 things. One is dead on arrival and checksum validation. So imagine that you shipped your OTA update and your app is crashing on start. So what you can do? Well, I guess you could send an email to all your clients and tell them to wait for a few days and download new bundle from the store. But probably you guess that automatic update will be much easier and better. So for this to work, your app needs to know if it's in a healthy state or not. So what do you think? What can be an indicator that your app is healthy? Any ideas? Well, for example, if you can render your login page or home page, it means that, okay, something worked. Or maybe you have a successful backend response. Or you can count a few navigation events. So it means that user can interact with your app. So let's consider the happy path. Once the OTA update is downloaded and it's already on the device, using Script Manager, we can apply this update during start. And then OTA update is like in evaluating state. So the idea is like canary release. And until your app will pass the canary checks and the update will pass the canary checks, we can just change the status to applied. And then if you will restart the app, your app will use the updated bundle because everything is working good. But if your app will crash after applying OTA update, but before passing health checks, your app will restart. It means that on the next boot, your OTA update will be still in evaluating state. So it means that something went wrong, and we just need to revert and fall back to the previous bundle that was working correctly. You can wait too long to run your health checks because, for example, they may be another reasons that your app will be closed, like dead battery, or system will close your app because out of memory, and app will be closed before actually changing the status to applied. And there is also a third part, when you ship OTA update that will crash your app, but somewhere in the settings or profile page. Of course, that on arrival won't be able to detect this because crash happened way after passing the health checks. That's why we call it dead on arrival, not dead after claiming your luggage. The another part that we needed to implement is checksum validation. It all started with a sentry error that we noticed. Compiling JS failed. Buffer is smaller than the size stated in the file header. Expected at least something bytes, but got something bytes. Buffer size something start with something. Just look at this. What a beautiful error, right? We had no idea what it was. But we noticed that this error happened only on the versions that we updated over the year. And CPP exception gave us a hint that probably it's something related to Hermes. So what we did is what every reasonable engineer would do. We started to reading the Hermes source code. And we found related code pretty easily. It turned out it was Hermes preventing us from doing just stupid things. It's doing the sanity check before executing your JavaScript bundle, and it checks if the size that it's stated in the header of the compiled bytecode matches the actual size of the file. And actually, we can verify it. And let's go even lower. I think this is the lowest level you will see during this conference. And let's have a look at the hex dump of the compiled bytecode. But it's really simple, I promise. As you can see, in the hex format, we can see that size is stored, and it actually matches the size of the file on the device. Why file can be invalid? Well, there may be a bunch of reasons. They may be invalid download or invalid error with extraction of the diff. It can be related to specific devices, file systems, like who knows? It can just happen. So what we did, we are verifying the files before applying the OTA update. Together with the diff, we are shipping the manifest file, where we list all of the chunks that are in the diff and the checksum. So we can calculate and validate the checksum on the device, and if there is a mismatch, we can just download again or zip the update again, and it's totally mitigated this error. It's interesting, actually, because I'm a software developer for like, I don't know, 15 years now or so, and actually this is the first time I actually needed to implement checksum validation. It's like, we don't think about stuff like this, right? It's like what you fetch is what you get, but it doesn't work at scale. Then we run into another issue. We noticed that on iOS, after applying OTA update, some of the images were not loading. So to understand what was going on, we need to have a look how React Native is working with images paths. In the React Native source code, somewhere, there is a class called Asset Source Resolver. And there is a part of this class, and you can see that there is a function that is returning a path on the file system to the asset. And you can see that for iOS, it's returning something called scaled assets URL near bundle. And we wanted to have a look what this function is actually returning. And it turned out it was returning a path to the non-existing file. Why? Because by default, this function is returning a path to the assets relative to the main JavaScript chunk. So if we applied another OTA update, we changed the location of the main chunk, and that's why the path was incorrectly resolved. So Luckily, the fix was easy. We wrote our custom resolver. On the native side, we exposed a constant that is returning the path to the original bundle, the one shipped with the when you installed the app, and just pointed in our custom resolver to use this path, and images started to work. So, since we're done with the technical part, I want also to briefly talk about the release process and OTA and stuff related to this. At Klarna, we release often, and I mean a lot. I don't know if you remember from second slide, but we have around 40 merges to the main branch per day, and we release new version to the store every single week. So, in the best case, if you will match your change to the main branch, first clients will get your code in just a matter of days. That's why we don't have continuous delivery with OTA. Every update is manually created and controlled by my team. And actually, Expo Docs puts it really well. Often safe and fast are opposing forces when delivering code to our users. And we are definitely on the safe side. So here is the few things that worth to keep in mind regarding the OTA releases. You need to remember that instant updates are not exactly instant. Users need to restart the app at least once, at least in our case, to apply the OTA update. And these updates can be applied right away. There may be, like we discussed, dead on arrival, download failures, unzip errors, all of this can delay it. So even if you will set rollout to 100% or run this magic command that all of your clients will get the OTA update, remember, it's not a hot reload, at least with this setup. It doesn't magically hit everyone instantly. Also remember that rollout percentages can be tricky. So imagine that you have version 1 that is already fully released to the store and it's already on 100 million users. If you will ship OTA update and set the rollout to 50%, it means that 50 million clients will get your update. But now imagine that you have a second version that you just started to release and it's only on 1% of your customers. In this case, if you will set OTA update to 50%, effectively only 500,000 users will get this new version. So it's 0.5% of total customers. So you need to keep in mind what version you're actually updating. Also, you need to remember, the faster you want to go, the more complex it gets. In our case, around 80% of all of our customers are on 3 versions. This is the one that we fully released, the one that we just started rolling out, and the one before that. So with 2 versions, you have actually 6 builds online, like live, available for users, because it's 3 releases per 2 platforms. And now imagine that you are applying OTA update on top of that. So we are ending up with 12 different versions live. So now imagine where you need to check your monitoring and Sentry and analytics. All of this, you need to prepare all of these tools to be able to handle these differences in versions. So let's summarize what we could talk about today. First, don't implement OTA bar yourself. It's probably not worth of your time. I mean, if you want to do it for fun, I'm not judging, it's completely fine. Or you have maybe super specialized use case, then it's also maybe okay. But most probably, you can just use some of the solutions that are ready to be used. There are just so many hidden complexities behind such solutions, and you can spend actually more time writing and maintaining this than working on your product. Now, probably we could go with Expo over-the-air updates, but disclaimer, I haven't used it. I just read the docs, and it looks really solid. I think it's covered everything, almost everything that we said today. Also, carefully read the documentation for the tool that you want to use. Does it handle that on arrival? Can you quickly revert your changes? Can it ship diffs instead of the whole bundle to save the network? or at least actually you need to know what is shipped and how it's applied on the device. Also, make sure that all of your analytics and all of the tools that we are using can pick up all the variations of like native version and OTA updates applied to it. And also do this mental exercise and consider multiple worst-case scenarios. So imagine that you have one version that is live and you need to apply over the OTA update on top of that. But maybe you need to apply another OTA even before the previous one reached all of your customers. And then maybe you need to roll back your changes and then make another native release because something went wrong on the native side, and then another OTA update. I know it's a lot, and probably it's not going to happen in reality, but it's a good mental exercise you need to practice so you are well aware what is the end state of the app on your client's device. So, thank you. That's all what I prepared for you today. I hope you enjoy this talk. If you want to talk about over-the-air updates or anything else, I also wonder if you have some experience with over-the-air updates, I will be happy to talk, so just feel free to approach and we have a chat. Thanks again, and enjoy the rest of the conference.